Hello, everyone. Thank you for joining our webinar today on the modernizing data workloads using Couchbase on Red Hat Openshift. So in this webinar, we will discuss what's driving the adoption of Couchbase on the Red Hat Openshift, which is an enterprise Kubernetes platform. We'll explore why the containerization of stateful application is about to go mainstream. And we'll also look at the challenges and available options with building a multi-cluster deployments of Couchbase on the Red Hat OpenShift. And what are the best practices for application deployment and data replication strategies to ensure data availability during the disaster recovery scenarios. And finally, we will demonstrate how you can use the Couchbase Autonomous Operator to run a fully managed stateful application on the Red Hat OpenShift. So before I get started, I'll give a quick introduction about myself. I'm Anil Kumar. I'm the Director of Product Management at Couchbase. I've been with Couchbase for more than 7 years, and I lead the product management team for our flagship product, Couchbase Server, Couchbase on Cloud, and also the Couchbase on Kubernetes product lines. Below are my LinkedIn profile and this Twitter handle if you would like to connect with me. So to lay the foundation, let's take a look at here are some of the key trends our customers are paying attention to today. Cloud native applications, AI and machine learning, IoT, and innovation culture. So the companies we know are moving rapidly away from the legacy systems to implement a new breed of highly integrated cloud-based systems. But the key ingredient to enable all these trending technologies is the adoption of containers, Kubernetes, microservices, and DevOps. So let's take a look, for instance, how the container transformed each of this, right? So when you look at the application development, before it used to be monolithic, and it changed to the entire applications. And now with the container, it is more of you see these microservice adoption, right? Microservice applications. Similarly, for the data center, it used to be more on the hosted. You would have your own data centers. Excuse me. So it used to have your own data centers with the bare metals and in your own VM farms. Now it is more on the hybrid cloud, where you have your own private cloud and you have deployments across multiple public clouds. Similarly, from the processes perspective, from a development processes perspective, it used to be more of waterfall, then changed to agile, and now it's all about the DevOps processes. So now let's take a look at, so when we started in the journey of Couchbase on containers and Kubernetes, so we looked at, we did a survey of number of Couchbase customers who are standardizing and actively evaluating Couchbase on containers and Kubernetes. So if you look at from 2015, we have seen a steady growth of customers who wants to standardize on running Couchbase on the containers and Kubernetes. Initially, you'd see there was a 5% of the customers who were interested, and now with 2018 and 2019, that number has significantly increased. So let's dig into this, right? So let's find out what's driving this adoption of containers and Kubernetes for stateful applications. So mainly what customers are looking for is, in terms of standardizing, is the standardization of development and production environment. So they want to have a consistency across the way they build this application and then the way they run these applications in production environments. So they want to standardize on the the tools and technologies. Right? Also, they want to run and manage the stateless and stateful applications together on the same platform. So before, what used to happen is with the containerization, they transformed their applications into the microservice architecture, and they were able to run their applications as a containerized applications on containers on Kubernetes, whereas their database, which is a stateful application, was running on a legacy systems, which was bare metals or VMs, and it was that created a silo between both the infrastructures. So you would run and manage your stateful applications on this modern platform, whereas your database is still running on the legacy systems. So now with the what customers are interested in doing is they want to standardize and run everything on an entire full stack of their applications on the same platform. So they can easily manage and run their application on the same platform. So they want to implement a DevOps for both the stateless and stateful applications, right? So the speed of delivery, the faster time to market is really important for the customers. So they want to bring in the DevOps methodology where they put the changes in the pipeline, and then the pipeline goes to the dev test, pre-production and production environment, right? There is also increased portability across infrastructure. So they want to be able to deploy on any of the infrastructure, be it a bare metal, VMs, private cloud, public cloud, or if they want to have a hybrid cloud. So they want to basically standardize on any of this infrastructure. And finally, the scalability and affordability. Right? So now let's take a look at why customers are picking Couchbase Autonomous Operator on the Red Hat Openshift platform. So before I talk about what we have done, so let's take a look at the journey we have taken thus far, right? So the journey for Couchbase started way earlier, back in even 2013, when we started experimenting with Couchbase on Docker containers. In 2015, we launched Couchbase beta version of Couchbase on containers. We created a Couchbase Docker image for Docker image and published it on the Docker Hub. And also we had a Couchbase on Kubernetes, which is also we published in the Docker Hub. So this was a beta, and then from there we started seeing some early customers, adopters who were interested in running Couchbase for at least in the development and test environments. And then we decided back in 2016 is when we decided that the Couchbase our goal was to help those customers who want to run Couchbase on containers. So we decided to production certify Couchbase on containers. So in 2016, with the Couchbase Server 4.5 release, we officially production certified running Couchbase on containers. From there, we knew that customers who are going to go in this journey will have challenges because Couchbase is a complex distributed database. To run a distributed database on a containers, you have to manage many things. Like if container dies, you should be able to bring them back. So we definitely needed a container orchestration. So we started looking at multiple solutions back then. In 2017, we were looking at Docker Swarm, we were looking at CoreOS, Tectonics. So and out of that, the Kubernetes emerged as a de facto standards. So we started looking at integrating Couchbase with the Kubernetes. So in 2017, we launched a POC of running Couchbase on Red Hat Openshift, which is an enterprise Kubernetes platform, using the concept called stateful sets of Kubernetes. In 2018, we production certified, basically we productized this POC and created a product called Couchbase Autonomous Operator for Kubernetes, and which is also production certified on Red Hat Openshift. So from there, our journey, we have added some major enhancements in 1.0 and then 1.2. And now we are working with on our next major milestone, which is the 2.0, which is targeted for end of Q1 2020. So what is the Couchbase Autonomous Operator, right? So if you look at this, the architecture, you'll see that at the core of it, which is at the heart of of this product, is it's a native integration with the Kubernetes. It has a Couchbase data platform. It's built in basically with it has the best practices of how to run and manage Couchbase data platform, and it is the Kubernetes operator, right? So there are features which we have shipped in the 1.0, 1.2 timeframe, which is the automated provisioning, upgrade, cloud. It's a fully cloud agnostic, centralized management, on-demand scaling, and automated availability. It is certified on all these platforms: open source Kubernetes, Red Hat Openshift, Google GKE, Azure AKS, and also the Amazon EKS. So why should we even think about running Couchbase on containers and Kubernetes? The number one is, if you are in the journey of adopting microservices, I was talking about earlier, you would run in the past, in the old days, you would run the database as a separate system on a separate infrastructure. So now with the Couchbase being on the containers and Kubernetes, you can think of running Couchbase as part of in the same platform. So your database is much closer to your microservices. It's in the same platform, so you can easily manage them. You can easily scale them, right? When you and also with the DevOps model, this whole process becomes completely streamlined. So if you're in the journey of if you're adopting hybrid cloud or multi-cloud strategy, you want to be agnostic to the infrastructure. If you want to build it once and deploy it anywhere, so in that case, the running Couchbase on the containers and Kubernetes completely makes sense, because you can go from one infrastructure to another infrastructure with zero chance of misconfiguration, because that's exactly what Kubernetes provides you. So it makes your application completely infrastructure agnostic. So finally, I'll leave it with this thought, which is the database management has transformed from being manual to automatic to be fully autonomous. And this is exactly what the goal of Couchbase Autonomous Operator is. So now let's take a look at a quick demo on how the Couchbase Autonomous Operator runs on the Red Hat Openshift, which is an enterprise Kubernetes platform. My colleague Evan Peace is the principal architect in Couchbase. He's going to do the demo on the Couchbase operator.
Thank you, Anil. And I will share my screen here in a second. I think you need to stop sharing, Anil, so I can grab the ball. There we go. Thank you for that. So as Anil mentioned, I am the partner architect here at Couchbase. I work very closely with Red Hat, and we're excited to demo this, our operator solution, to you all today. So first I want to set the stage a little bit. What I'm going to do for the demo is deploy an application that's running on top of Couchbase, and it's going to be streaming some data in real time from Twitter into Couchbase. It's just so that we have a data set so that we can show you that we're doing all these operations in the background and we're not losing data, and that things are running smoothly while the operator is taking over the operations of our cluster for us. So let's go ahead and jump in. The first thing I want to show you is how to deploy a Couchbase cluster on OpenShift. Now, I've already gone ahead and done this because it does take a few minutes for a cluster to get fully up and running, and I don't want to delay the demo. So I went ahead and did that ahead of time. But I think what I can do is show you what that process looks like, even if we don't actually execute it. So I'm going to go into a project. We are in the Operator Hub catalog. So if you go to Operator Hub with an OpenShift and search for Couchbase, you'll see this right here. Click Install. And I'm just going to install it into this project. We'll see the operator get installed here. It'll just take a moment. Okay, so the operator is now installed in this new project. And so we obviously did use Operator Hub here to install the operator. You don't have to go that route. You can obviously also use the command line, the OC controls to do the installation the traditional way. Let's go ahead and click on the operator. We can click on Couchbase Cluster. We don't have one yet. Click Create Couchbase Cluster. Here it will pre-populate the YAML for us. So this is the CRD, custom resource definition for Couchbase clusters. So what we do with the CRD, this is YAML configuration you're looking at, is try to encapsulate all of the typical operational knobs and dials that you would want to turn when you're configuring and designing a topology of your Couchbase cluster. So this is a very simple bare bones example that it's packaged with. I'll show you some more advanced examples at the end, but this is a very basic one to just quickly get a 3-node cluster up and running. Now I've already done this in my other project. So let's go to project CB example. Now in here, let's go to Operator Hub. Excuse me, let's go to Install Operators, click on this. You can see we've already got a cluster here. And here are the resources associated with that cluster. So I've got a 3-node cluster. You can see a CB example 00, 01, 02, and 1 and 2. That's a 3-node cluster. I've also exposed the Couchbase Admin UI, which you can see here. I'm logged into it right here. I have a bucket called tweets. There's no data in that yet, so let me go ahead and kick that off. It's just going to start ingesting data here for us in a second. Once that happens, you'll start seeing data, this item count increment as the data comes in. You'll also see this dashboard. This is the Twitter application I showed the screenshot of in the beginning. You start seeing this dashboard light up with some metrics and some of the live tweets coming in. Again, this is just so we have some data flowing in real time so that we can continue with the demo and show some operations in the background. So this will take a minute or two. The first thing I thought I would do is to show you how to scale the cluster. Oh, here we go. There's some data flowing in now. So let's go ahead and look at what the process looks like for scaling the cluster. So here's the YAML file that I had used for this cluster. So let's say we wanted to add a 4th node. So I'm going to go down here to size in my CRD, change this to 4, save it. Now I could copy and paste this in the Couchbase, or excuse me, in the Openshift UI. In this case, I'm just going to do this from the command line. So I'm going to OC replace -f Couchbase cluster.yaml. So what this will do is look at the name of my cluster, which is CB example. The operator will see that this cluster already exists and that we're changing the CRD, and so it will bring the cluster to our desired state. In this case, we're changing it from 3 to 4 nodes. Let's go ahead and execute this. What's going to happen are a couple of things. On the Couchbase side, we'll see a CB example 003 pod get created. There it is right now. It's pending. So this new pod, this is a new Couchbase node that's coming online. After this is done coming online, you can watch it come online here on the Couchbase side as well. Usually just takes a couple of seconds. And when this new node is fully online, it'll rebalance the data so that we've got the data distributed evenly across the cluster. So there you go. So, and again, while all this is happening, we have this application running. It's refreshing every 5 seconds automatically with any of the new data. So no interruption to our service here while this is going on. But for the next demo I thought I'd do is, let's just go ahead and take a look at our pods. Let's simulate a node failure. Like, let's pretend we lost whatever OpenShift nodes and we lost a Couchbase pod. Doesn't matter which one. But let's go ahead and kill CB example 002 just for demonstration purposes to watch what happens. Let's see, delete pod CB example 0002. Okay, so just deleted that one. Let's hop back over to our Couchbase admin. So what we should see happen, I may have got logged out here. That can happen, yep. If you, by chance, kill the node that you are connected to, you'll get logged out. You can see that we lost one of our pods is not responsive, one of our nodes is not responding. So you can see that here. Let's go back to buckets. You can see data is still coming into our tweets bucket. There's no interruption in the ingestion of the data. The app here is still serving the data, no problem. So no interruption, even though we lost a node. On the OpenShift side, again, a new pod's getting created, new Couchbase nodes coming online, and the data will rebalance. So we just healed the cluster from a failure. And then finally, I think what I thought I'd do for the last demo, and the limited time that we have, is just upgrade the cluster. So which is another painful, typical operation to do manually. Show how the operator can automate that for us. So let's go increment this from 6.0.3 to 6.4. You can upgrade all the way to 6.5 this way. I've tested that as well. And we plan to support major rolling upgrades and things like that. They're changing it to 6.0.04. Let's do weights again. Let me just make sure the rebalance is done. Yeah, it is. Okay. Now we're changing the version from 6.0.3 to 6.0.4. So what will happen here is on the OpenShift side, we'll start seeing new pods come online. So you have CB example 005 coming online. This new pod is going to be running Couchbase 6.0.4, the new version I just asked for. Once this is done, it's going to rebalance the data into the cluster, and then it's going to take one of the old pods that's running the old version down, and then repeat that process over and over again until the entire cluster has been updated. So that's how we do rolling upgrades. So our cluster is now upgrading itself to the newest version of Couchbase. And again, all along, you've got data flowing. There's zero interruption to our application here. We're not losing any data or any other issues. We're able to do this while our service is online. And that's going to conclude the sort of interactive part of the demo. I thought what I would do before I close is quickly show a couple more advanced examples of a Couchbase cluster. In production, you're probably going to be leveraging our multi-dimensional scaling functionality. Your OpenShift cluster may be deployed across multiple availability zones, things like that. So this example shows a couple of things. It shows server groups, which is how we can distribute a cluster evenly across availability zones. So my OpenShift cluster is actually deployed across US West 2A and US West 2B. And there's all of the OpenShift nodes are labeled with the availability zone that they're in. So you can use the value of that label to distribute your cluster evenly across the availability zones. And so define a data class, which is data index here. And then here I've got a query class. This is arbitrary. You can create this name for this class is arbitrary. So you could have a full text search class, an analytics class, whatever services you need to use. And you can set the size separately. And again, it'll be distributed evenly across whatever server groups you've defined. In this case, we have 2 availability zones we're using. So basically, this is how we do multidimensional scaling through OpenShift, and how you can distribute, design the topology here, essentially. So, okay, and then also one last thing here that we're doing is persistent volumes. You get major performance benefits, especially with rebalancing if you're using persistent volumes, which is a good practice with stateful applications to begin with. So we support any of the storage classes that support the dynamic provisioning in Kubernetes for persistent volumes. And with that, I'll close the demo. So I mentioned one more thing as well. I didn't show it in this demo, but cross data center replication is another major feature of Couchbase, which has been there long before Docker and Kubernetes were. One of the things that Couchbase has been really popular over is the ease at which you can do cross data center replication. So when you're thinking about multi-cloud and hybrid cloud strategies, it's really easy to take all that YAML I just used and run it on a Kubernetes or OpenShift cluster somewhere else, and set up XDCR to have the data flow over the WAN to another cluster. So I just wanted to call it out as well, since we want to focus on that. And that's it for my demo.
Hey, thank you, Evan. So before I close, the current version of Couchbase Autonomous Operator, which is production ready and production certified on the Red Hat Openshift platform, is 1.2.2. And we went through a bunch of the enhancements and features we worked in those release. For the 2.0, which is in the short-term roadmap, we are tentatively targeting it for May-June timeframe of this year. So I want to just quickly call out some of the highlights of the 2.0 release, which is going to be a major release. So some of the highlights when we talked about the Couchbase deployment on Red Hat Openshift. So in the past, we would just it was automated provisioning. As Evan was showing you the CRD, which has the blueprint of your Couchbase deployment. You define what Couchbase cluster settings you want to have, what topology you want to have. You define all of that. But as far as security is concerned, so that was done after the Couchbase the cluster was deployed. So you would first deploy the Couchbase cluster, then as an administrator, you go log into the Couchbase console or use the REST APIs or CLI to go and create the users and give them the access to the Couchbase database. With the Operator 2.0, what's going to happen is we will have a CRD for even security. So you define which users are going to be created and what roles they will have for the Couchbase deployment. So that part is also going to be fully automated as part of the provisioning itself. So when your Couchbase cluster gets deployed, it will also will have the users created and also the roles assigned to them. And one of the security features in Couchbase data server, Couchbase server data platform is LDAP and LDAP groups integration. So that will also be fully supported with the operator. So you can define your LDAP group or LDAP users, and then what roles and access they have in that CRD itself, and that will also be taken care of by the operator. And the next major enhancement is the backup. So backup operation was, once your Couchbase server is up and running, we had documentation, we had tutorials in our official documentation where you will create a cron job to schedule the backups and take the backup of your Couchbase server database. With the Operator 2.0, we'll have a separate CRD for the backup itself, where you can define the schedules for your backup. How often do you want to run this backup, and also you will have the visibility into the backups running. We'll have logs and events created, so when backup is kicked off and when backup is completed. So all of that will be done by the operator itself. And increasingly, we have been finding out a lot of customers with this journey with the microservices and running it on the containers and Kubernetes. What they typically use for monitoring is Prometheus. So what we did in the 2.0 timeframe is we also built an official exporter, Couchbase exporter for Prometheus. With this official Couchbase exporter for Prometheus, now it will be much easier for you to configure this exporter, which will export the Couchbase stats from Couchbase deployments to the Prometheus. And we'll also provide you the Grafana template where you can visualize this whole Couchbase deployments in centralized place, right? So this is also another major enhancement which is coming in the Operator 2.0. And there are other bunch of improvements. We are looking at integration with the Open Service Broker APIs. We are also have a new security model for the operator, and there are other bunch of other enhancements which are we are targeting for the Operator 2.0, right? So stay tuned and look out for at the blog.couchbase.com for any updates on the product enhancements coming for the Couchbase Autonomous Operator. Again, thank you for attending this webinar. Bye-bye.